All right. Morning, Luke. Thanks for letting me know you're having a hard time with this one. Thought it's probably easier if I just make you a quick little video, and we'll see how we're going. So we're having a look at this problem where root 3 cos x plus sine x equals r cos x minus alpha. First of all, why are we doing this? Because this guy is a whole lot easier to graph. Okay, so if you've got something with some cos and some sine, you might get asked to graph it. It's a little bit difficult. Hopefully this you start to recognize a bit more from methods and what we have been doing in specialist, where R is just going to be your amplitude, so that'll tell you your maximum and minimum values. And then hopefully remember this is going to be a horizontal shift, and X is going to be our angle. The other thing that you need to solve this question is remembering what cos A minus B is. So that was in our last section where we were doing the difference of angles. Okay, so the first step is to rewrite our right-hand side. We're going to leave the left-hand side alone for the moment. We're going to rewrite our right-hand side as R. So the difference for cos goes cos of angle A, cos of angle B, opposite sine to what's going on here, plus sine of angle A, sine of angle B. All right, I'm going to start referring to them as A and B because in this problem they are X and alpha. And all of that is multiplied by R, so I'll chuck my brackets around it. Next, I'm going to expand this out so that I end up with R cos X cos alpha plus R sine X sine alpha. Now, where some students got lost in the class next is what happens in your worked example, is what it's really doing is it's equating this part. So I'm now just going to call this 1 to help us out, saying root 3 cos x, because these things equal each other, must then equal r cos x cos alpha. Yep. Because that gets us our cos part of the problem. So we had root 3 cos x here, and we're saying that's the same as r cos x cos alpha. And then I'll just set up equation 2 while I'm at it. And that is saying that the sine component, which is sine x, equals r sine x sine alpha. What you then want to realize is that you have cos x on both sides, and you have sine x on both sides. And so what we can do is if we subtract or we divide both sides by cos x, they're going to disappear from each, and what we're left with is root 3 equaling r cos alpha. And similarly on our second part of the equation here, we are going to have the sine x's cancel each other out. If we divide both sides by sine x, we are left with 1 equals r sine alpha. Excuse me. Okay, so hopefully you're all good with us up to there. Now what we're just doing is we're going to, basically we're trying to cancel for r, and the way that we can do that is dividing our equations by each other. Now, we could divide 1 by 2, but hopefully you know what sine over cos gets us. That gets us tan every time, okay? And that actually makes our life a little bit easier. If we did cos over sine, we'd get cot, and we'd have to do a little bit more rearrangement. So it's just about making a choice here, about recognizing your patterns, and it's going to be easier if we have sine over cos. And so what the textbook tells you to do is if you do equation 2 divided by equation 1, on one side of it, you are going to have 1 divided by root 3. On the other side of it, you are going to have r sine alpha divided by r cos alpha. Okay, so equation 1, after I've done some cancelling out, goes on the bottom, and that's my 3 equals r cos alpha, and my equation 2 is what I've got on top, 1 equals r cos alpha. R divided by r cancels out, and I'm left with 1 over root 3, remembering that tan of A over cos of A, sine of A over cos of alpha is equal to tan alpha. From that point, you would want to check your triangles. So I'll draw it up for you. We've got 1, we've got root 3, and we've got 2. Hopefully you can remember what tan is, opposite over adjacent. So if I've got 1 on the bottom, it means I'm talking about this angle up here, which is pi on 6. Okay, so I could then say that, because what I'm really doing then is inverse tan 1 on root 3 equals alpha. The exact value of that we know to be pi on 6. Okay, just have a look at that. I'm going to need to wipe that off so I can keep working on the board, but that's where we're up to at the moment. Pi on 6 is equal to alpha. Okay, so I've just cleared some space. I've left my final bit, which is alpha equaling pi on 6, and I've also left my triangle. Unfortunately, what I did rub off was what we're probably going to want to use, which is that equation 1, which was root 3 equals r cos alpha. Okay, because the problem originally is that we had 2 unknowns. We didn't know r, we didn't know alpha. Now that we have calculated alpha, we can use that to work out what our r should be. So we've got root 3 now equaling...
There is a year 7 and 8
we'll just wait for that to stop.
In the hall. There is a year 7 and 8 assembly this morning in the hall. Thank you.
Okay. So we've got root 3 equals r cos pi on 6. We go back to our triangle, pi on 6, and remember that cos is adjacent over hypotenuse. So that's going to be equal to root 3 is equal to r root 3 on 2. Yep. The easiest way to solve for r now is to divide by root 3 on 2. If we want to divide by a fraction, we multiply by the reciprocal. So I'm going to do root 3 on 1 multiplied by 2 on root 3. And that's going to equal r. 2 root 3 on root 3 equals r. I have to rub this last little bit out. And so r is 2. The final thing now is to finish our equation off. So I actually just come back up here, and I can now say that all of this, excuse me, is equal to my calculated r, which is 2 cos of x minus alpha, which was pi on 6. And that would be our expected answer. I got to run to class now. I hope that helps. I will email you this video now. Have a look at it. Let me know how you go.